Hello and welcome to this exciting calculation in physics. This question says a cell of EMF 4.5 volt is connected in series with a resistance of 8 ohm and an ammeter of resistance 6 ohms. We should calculate the internal resistance of the cell and the potential difference across the terminals if 0.2 amperes of current passes. Start with solution. Now first, they say the cell has an EMF of 4.5 volts. It is connected in series, so series total resistance is going to be 8 plus 6, which is 14 ohms, right? Because they say they are connected in series. Now, another parameter given is the current. What you should know is that in a series connection, right, current is the same all over the circuits, while in parallel connection voltage is the same. Okay, so it means our total current is what? 0.2 ampere. So now, what formula relates EMF, resistance, current, and internal resistance that they say we should look for? And the formula is nothing but I is equals to E all over R plus R. So here we can either substitute value and solve now, or make small r, which is the internal resistance, subject to the formula. This E is your EMF, I is your current, R is your total resistance in the circuit, and or you call it overall resistance, and this small r is your internal resistance. So if you want to make it cross multiply, so I into R plus R is equals to what? E. If we expand this bracket now, we have IR plus IR is equals to E. So let's remove this so that we'll have only this here. IR is equals to E minus IR. And then since we are looking for small r, then small r will be equals to E minus IR all divided by I. This step is not compulsory. You can just substitute your value here or here and find R, please. Okay, so R is equals to EMF is 4.5 minus current is 0.2 times total resistance is 14, all divided by current 0.2. So we're going to be having 4.5 minus, so let's take 0.2 times 14. So we're going to be having 2.8, all divided by 0.2. So your internal resistance will be 4.5 minus 2.8 will give you 1.7, all divided by 0.2. So divide by 0.2. So we're going to be having 8.5 ohms. So note that the general resistance is always higher than the internal resistance, right? Okay, so we have answered the first one. So if this I, we have answered it. And then we're going to II. They say we should calculate the PD, potential difference across the terminals. So we have PD. We know that PD is current times resistance, right? And our current is 0.2. Remember, we say current is the same. And our total resistance is 14 ohms. So we have 0.2 times 14. So we're going to be having 2.8 volts. PD is in volts. So this is our potential difference. Now, another thing you need to know is, since you have gotten the potential difference, they can also ask you to calculate the lost voltage, right? Because look, we have two voltages here. We have the one for 4.5, which is for the battery, and then we have 2.8, which is the PD across the terminals. But then there is something we call lost voltage. So the lost voltage is 1.7 volt. In case they asked, some questions may not ask, but I'm just always going extra miles to help students understand that some questions that are short, or some questions that are just the way they are, they can have extensions, right? So this extension for this one, lost voltage. So you say EMF minus PD, you get your value. Here we have 1.7 volt. All right, I'll call it enough here, and then we'll see in other videos. Bye.